And we are back for lesson 4. So moving on a little bit today, let's have a look at the learning objectives. Describing the changes you might see when compounds are formed. Fairly straightforward. We're going to spend most of our time this lesson on that second learning objective, identifying elements, compounds and mixtures from particle diagrams. And then we're going to name some simple compounds, which should be fairly straightforward. So let's just start with the very first one very quickly, which is, can we explain what we might see when compounds are formed? Well, compounds are formed in chemical reactions. Yeah, when we take two elements and we react them together so they stick together, it's a chemical reaction. We're making something new. So if I want to make water, I can take hydrogen over here, I can take oxygen over here, and I can react them together to make something new that isn't hydrogen or oxygen. It's a compound. So to answer this question, what might we see when compounds are formed, we're really just going to answer the question, what do we see when there's a chemical reaction? I'm sure you've spoken a lot about that in lessons already. We might see a colour change. We might see some light being given off. We might see bubbling as a gas is formed. We might feel a temperature change. The temperature may increase. Yeah, it might be an exothermic reaction. The temperature goes up. The temperature might go down. It might be an endothermic reaction. But any of those things are good indicators of a chemical reaction. A colour change may also be a good indicator of a chemical reaction. And if a chemical reaction is happening, then we are producing a new substance. We're producing a compound. So that one is out the way. Let's have a look at our second objective. That's going to be the bulk of this lesson. Can we identify compounds, mixtures, and elements, compounds, and mixtures from descriptions and particle diagrams? I want to concentrate on the particle diagrams. And we're going to have a look at this. We have 9 different diagrams. How would we accurately explain each one? What kind of terminology will be used? Well, I'm going to walk you through it. And then you'll have some practice on that in the worksheet sent to you, I'm sure. Question A. Well, or box A. How would I describe that? Well, what do I have in box A? I have atoms that are joined together. I have a big pink one and a little blue one, and they are joined together. Now, the big pink one and the little blue one are obviously different types of atom. So that is a compound. So in box A, we simply just have a compound. There's no other substance in there. It's just one single compound. And that's what I call it. Let's move on to box B. Now in box B, I have 2 different things, 2 different types of atom. But unlike box A, they're not bonded together. Yeah, in box A, the little blue ones are stuck to the big pink ones. In box B, I have 2 light blue ones that are stuck together. And then I have these other blue ones that are not stuck to them, a different type of substance, different type of atom. So B is going to be a mixture. It's a mixture because I have 2 different types of substance, but they're not joined together. Those little blue ones are not stuck to the big blue ones. So it's a mixture. Remember, a mixture is when we have more than one substance, but they're not joined together. Now, how else might I describe this? Well, let's look at the 2 different substances we've got. First of all, let's look at those little blue ones. That's an element. There's only one type of atom there. Okay, those little blue ones, they're an element. When we look at the big ones, the big blue ones stuck together, well, we can see that actually they're also elements. Even though they are molecules, we've got things stuck together, the types of atom that are stuck together are the same type of atom. There's only one type of atom in that molecule. So I'm going to redefine what I just said about box B, and I'm going to say, yes, it's a mixture, but it's a mixture of elements. Let's go to box C. I can see an element. I can see those big pink atoms are an element. But I can also see, floating around in there as well, is a compound. I've got those little yellow atoms stuck to those little blue ones. 2 different types of atoms stuck together is a compound. So this is also a mixture, but it is a mixture of one element and one compound. And this is the kind of language we're going to use when we're describing this properly. I'm not just going to say mixture. I'm going to really dig deep and define what it's a mixture of. And this is a mixture of one element and one compound. We go to box D. I'm going to give you the chance now. Pause the video and then tell me what you think we find in box D. Now, hopefully you've paused it, and hopefully you've just said, it's a compound. It's not a mixture, it is just a compound. We have 4 or 3 different types of atom joined together to make molecules that are 4 atoms big, but all those molecules are the same, it's the same compound, so it's not a mixture. Let's see what you get for E. And again, hopefully you paused the video, had a think, and hopefully you told me that E was an element. Again, it's not a mixture. Now, these elements are in the form of a molecule, like O2 for oxygen, or N2 or Cl2, but they are an element. There's only one type of atom there. Again, I'll pause it while you have a think about F. Okay, hopefully you said F was also an element. Let's look at G. Little bit harder, this one. A little bit harder. Now, hopefully, after you've paused the video and had some thinking time about it, you've realised that we have 2 different types of compound there. We have the big pink ones stuck to the little yellow ones, and we have the 2 big pink ones stuck to the little blue one. They are 2 different types of compound. So this is a mixture of 2 compounds. That's how we would describe that, a mixture of 2 compounds. H. Right, hopefully you've had some thinking time, maybe you've paused the video. H is just an element. There is only one type of atom there. It is an element. Now that element is arranged in a very large structure. You may even hear the word or term lattice as you get older. But there is only one type of atom there, that little yellow atom, so that is an element. I'll give you a few seconds to think what I might be. And again, I is just a compound. It's not a mixture, it is a compound. We have molecules that are 3 atoms big, but those atoms are not necessarily the same type of atom. So, I think that's point number 1 ticked off. I think that's point number 2 ticked off. Now name some simple compounds. I am going to name some simple compounds. But what I'm going to want you to do is when I've named them, I want you to write them down and I want you to go onto the internet and see if you can find out what elements make up these compounds. And I want you to see if you can tell me not just what elements make up these compounds, but how many atoms of each element are in there. So I'll give you an example. If I said to you water, you'd go to the internet and you'd type in the chemical formula for water and you'd get the answer H2O. And then from that you would work out that H2 means we've got 2 hydrogen atoms and the O, we have 1 oxygen atom. So you give me the chemical formula and you give me the number of each type of atom in there. I'm going to name 5 and hopefully you'll get them right. So your first one, carbon dioxide. Your second one, methane. Your third one, sulfuric acid. Sulfuric acid. Your fourth one, potassium nitrate. And your fifth one, calcium carbonate. So see if you can go on the internet, type those in, find what the chemical formulas are for those, and then see if you can figure out what elements there are. And I will give you the answers next time. You will also have on the class charts for this lesson some worksheets that have been sent to you that will help you practice all this as well. So good luck with those. See you soon.